Before he went to the Winter Olympics, he went to see science on an epic scale. This is so cool. Check it out.
Our universe. It's incredible, full of natural wonders that have fascinated us for centuries. Like my hair.
But how much do we actually know about how it all started? The world, the galaxy, the universe.
Many scientists believe the universe began with the Big Bang, a massive explosion nearly 14 billion years ago. And that by recreating the Big Bang, they'll find out more about how the universe began.
So how do you recreate the Big Bang? Okay. Bang! Nah. Bang! Still not enough. I know. Bang! No. I'm gonna need something a lot bigger.
Thankfully then, the European Organisation for Nuclear Research built the world's biggest machine to do just that. It's called the Large Hadron Collider and is run by a team of thousands of technicians, engineers and scientists. Scientists like Sudan.
So the Large Hadron Collider is a 27-kilometre particle accelerator built 100 metres under the ground of the French and Swiss countryside.
This is the largest science experiment ever, and I've come to Switzerland to pay it a visit.
And here it is, the Large Hadron Collider, and this thing does... Okay, I don't really know. Can I have some help, please?
The Large Hadron Collider accelerates particles at very high speeds, close to the speed of light, in fact, and then bashes them together really, really fast, and then we see what happens from those collisions.
So the idea is that by crashing particles into each other, this machine will recreate lots of tiny Big Bangs, which can be studied. And I've been allowed access to find out more about how it works.
Sudan, when I was in school, I loved it in science when they made it simple. So with that in mind, what actually is a particle?
Everything around us, your hat, even us, if we break it down into the smallest possible bit, that is what we call a particle. Just to give you an idea of how small that really is, if you take a grain of sand,
yes,
which you know is very small,
yeah,
there are 100 million particles in it.
So that's 100 with 18 zeros of particles.
In a grain of sand.
That is so small.
To study something so small, you need some pretty big scientific equipment. And when I say big, I mean the size of 3 double-decker buses. And that's the first stop on my tour.
Sudan, this is the biggest science experiment I've ever seen in my entire life. Okay, so I know particles are really small. So why is this so big?
This piece of equipment is like a camera, a digital camera. You can imagine cameras, you know, you sometimes hear 10 megapixels, 20 megapixels. This is a 100 million pixel camera taking photos 40 million times a second.
Right now, this massive experiment is closed for maintenance, so I'm going to areas that few people are ever allowed to visit.
We are 100 meters underground, and the scale of this place is off the charts. So the guys here don't always walk to get around. They've come up with a rather genius method, not just any old push bike. Oh, no, no, no. What is this, Sam?
Hey, Radzi. This is an electric bike that I used to get around because there's such long distances between points in the LHC.
It looks like an awful lot of fun. And what about yourself? What's your job?
So I'm an engineer here. It's not just physicists that work at CERN. There are many, many different professions here. Engineers look after, fix, maintain and design new parts of the LHC.
Actually, that variety is brilliant for you at home, because if you'd one day like to work here, you could. Well, Sam, I won't hold you up. Off you go on your awesome bike.
See you later.
The Large Hadron Collider is so big, it spreads beneath 2 countries. But why is it so big? And why is it a circle? Well, scientist Alex is going to demonstrate.
That means we need our safety specs.
Absolutely.
We're using liquid nitrogen to cool special magnets. This changes how they work and keeps our Blue Peter badge on the circular track.
And this is a small circle.
Yeah.
I know the Large Hadron Collider is a really big circle. Is it similar?
It's the same general idea of trying to get the particles to go round on themselves so that we don't have to build a straight line that just wouldn't fit on planet Earth.
So the magnets help bend it and keep it inside that circle.
That's exactly right.
The particles need to travel at nearly the speed of light, and a circle means they can spin round and round, getting faster and faster.
You've got it.
It's been an absolute pleasure.
Me too.
Do you know what? Science is awesome.
The people working here are trying to make discoveries that could change the way we see the universe, and it's been a privilege to meet them.
You're clearly very passionate. How much do you enjoy your job?
I absolutely love my job, Raz. I'm here in the world's largest scientific laboratory, really pushing boundaries of knowledge, trying to find out questions that humanity's been seeking since the dawn of time, I would say.
Who knows what they and this mighty machine might discover in the future.
This place has genuinely blown my mind. And the reason for that is because one of life's biggest questions is about how life itself started. And we're finding out that answer because of what happens inside there, which is why we've left them with a Blue Peter plaque.
This plaque will be kept here to celebrate Blue Peter's 60th birthday.
What a place and what an unforgettable day.
I love when Radzi wears a hard hat. That's making me miss him. It would take the average person 5 hours to walk around that collider. It's big.
It certainly is. That's 16.5 miles, or get this, 33,500 steps.
Whoa.
Yeah, I know. It brings us nicely on to our 2018 Sport Relief Check.